bonus section. Here we go. We're going to talk about the values of trigonometric functions, which really means that we're going to be talking about how do you find the sine, cosine, and tangent, and by extension, cosecant, secant, and cotangent of quadrantal angles. So angles that are 0, 90, 180, 270, things like that. Okay, so what we're going to do here, I have a diagram that I am going to show you that you can use to actually calculate, based off of the definitions of sine, cosine, and tangent, when the angle is on the x or y axis. So, for example, we're going to start off with 0 degrees, which means that your ray is actually on top of the x-axis, the positive x-axis. And so there really technically is no triangle here. So if you were going to talk about an opposite or an adjacent or a hypotenuse side, there is no right triangle to have those values. So what we're going to do is I'm going to take this ray and I'm going to shift it up just a little bit so I can visualize this imaginary triangle that might be there. So this is what it would look like. So here's my ray that I've just shifted up. Now technically what you have to think about is that this ray is still lying on the positive x-axis. So this height right here doesn't exist. So that height actually has a value of 0. Okay? Now the length of this ray, we can make it however long we want it to be. I'm just choosing 1 because it's the easiest number to use. So I'm going to put 1 right there. And then you have to remember that this ray is on top of another ray, or this length right here. So we can say that this x value, or this length right here of the x-axis, should be the same as this ray. So it's also going to have a length of 1. So the angle that we are concerned about is right here. And this should be 0 degrees. So technically this isn't anything. But now we have a right angle here that we can use a right triangle with the opposite and the adjacent and the hypotenuse to calculate sine, cosine, and tangent. So you can see that the sine of 0 would be opposite over hypotenuse, so that's 0 over 1, which is 0. And then cosine, which is adjacent over hypotenuse, that's 1 over 1, so it's 1. And then tangent is opposite over adjacent, so 0 over 1, once again, is 0. So those are the 3 values, sine, cosine, and tangent, of 0 degrees, or even 360 degrees if you had rotated all the way around. Now, if you wanted to figure out what cosecant, secant, and cotangent were, you just take the reciprocal of these numbers. So think about what would happen if you took the reciprocal of 0. Well, 0 is 0 over 1, so now you get 1 over 0. And then you think about it, can you divide by 0? Not really, so the cosecant of 0 is undefined. Same thing with cotangent, it's also going to be undefined. But the reciprocal of 1 is just 1, so secant of 0 is also 1. Okay, so what we're going to do here is we're going to do this same process for every single quadrantal angle. We're going to make a little triangle like this and plug in the values of 0 and 1, and then look at that triangle to calculate sine, cosine, and tangent. So here is the 90-degree angle. So what we're doing is we're going to take this ray and we're going to scoot it over. You can scoot it over to the left or the right, whichever one you prefer. I usually like to go to the right. So I'm going to scoot it over to the right just a little bit. And yes, this right here is a right angle because I'm dropping that down, right? But what you have to remember is that this right here is the angle that we are actually calling theta, or 90 degrees. Okay? Now, because I scooted this over a little bit, technically this ray should be on the positive y-axis. This length right here doesn't exist, so that's 0. And then the ray is 1, and therefore this is also 1. So now when I look at this and I talk about the sine of 90 degrees, I'm talking about this blue angle right here being 90, not that 90. Okay, so this 90, we get the sine is opposite over hypotenuse. Okay, and then cosine is going to be adjacent over hypotenuse, and then tangent opposite over adjacent. Okay, so notice that this time we did get an undefined because we have opposite, which is 1, over the adjacent, which is 0. Okay, so let's try it at 180 degrees. Okay, now I have this at -1 because I'm going in the negative direction. So when I take this ray and I scoot it up just a little bit, this length right here should be -1, but remember that this ray or radius should always be positive. So it has the same length, we just don't deal with the direction with the negative there. So this is a positive one, this is a -1. This is still 0 because technically this ray is supposed to be sitting right here at the negative x-axis. So the sine of 180 is 0, opposite over hypotenuse. The cosine of 180, now this is going to be -1. So this is adjacent over hypotenuse. And then tangent is also 0. So if you go back and you look at what the values for sine, cosine, and tangent of 0 degrees are, it's all the same except this one was a positive 1 instead of a -1. And that's just because we're pointing in the negative direction. Okay, let's take a look at 270. So 270 is pointing down, so this is a -1 once again. I'm going to scoot this over to the right a little bit, this distance here being 0, this being a positive 1, but this going down being a -1. And when I look at this and I evaluate the sine, cosine, and tangent, you can follow along based off of all the previous examples. Okay, so now what you're going to do is you're either going to memorize what all of these are, or you're going to feel comfortable enough to make these triangles each time that you need to figure it out. Or if you're lucky enough to be able to have a calculator while you're doing these things, you can of course just plug it in and hit the right button and it'll give you the answer. But I don't recommend that way. You get reliant on the calculator, then you get lazy. Okay, so we're doing more in this section, and that is we're going to be talking about the 30, 60, 90, and the 45, 45, 90 triangles. These are really important in trig. We deal with these all the time. So if our theta is 30 degrees, that puts us over here in the first quadrant, and you should remember the 1, 2, square root 3 relationship for your 30, 60, 90 triangle. So if I look at this and then go to evaluate sine, cosine, and tangent, sine is going to be 1/2, cosine is √3/2, and tangent is 1 over √3, which, when you rationalize, gives you √3/3. Now, I ask you, what would happen if I divide all sides by 2? So take each one of these numbers and divide by 2. And look at what you get. There's sine, there's cosine. Isn't that cool? So the reason that we divided by 2 is because we wanted the length of this radius or hypotenuse to be 1 unit. Okay? Pretty neat. Let's try it with the 45, 45, 90 triangle. Okay, I guess I put that 45 in before the triangle. Interesting. All right, so here's our triangle. They tell us that the radius is supposed to be √2. So that helps us out by knowing that each of these sides is going to be 1. So the sine of 45 is √2/2, because 1 over √2 when you rationalize. And cosine of 45 should be the same thing. And then the tangent, 1 over 1, is just going to give us 1. Okay, so like we did before, if I wanted to make this 1 unit, I'd have to divide everything by √2. So if I divide all sides by √2, look at what I get. Once again, I get sine and cosine. Now, if you're looking at this, how do you think you could get tangent based off of these 3 numbers in orange? Where are you getting this? So if you think about it, tangent is opposite over adjacent. So if I take this number divided by that number, you get tangent. So just think about that. And if this is sine and this is cosine, couldn't we define tangent as being sine divided by cosine? Oh, pretty cool. Okay, things to come. All right, one last example. So if they give you an angle that's not in the first quadrant, you're going to find the reference angle and the reference triangle. We've talked about the reference angles before. So when you look at this, theta being 240 degrees, that's going to put us down here into the third quadrant. So if I drew my reference triangle, in order to figure this out, because they didn't give us the sides, right? They haven't told us anything to give us the lengths of these three sides. What we're hoping is that the reference angle is going to be one of our special angles, 30, 60, or 45. So we need to figure out what this angle is right here, this angle, which is your reference angle. So if you recall, a few days ago, we talked about how do you find a reference angle depending on what quadrant you're in. So if this entire angle going all the way around to here is 240, and we subtract this, which is 180, we should have the remaining piece left over. So the reference angle is going to be 60 degrees. So once we know that that's 60 degrees, now we can fill in the side lengths based off of our 30, 60, 90 special triangle. So the side opposite 60 is going to be root 3, the side opposite 30 is going to be 1, and hypotenuse is 2. But we have to remember to put the negative signs because we're over here in the third quadrant. So x is negative, y is negative, but remember hypotenuse is always positive. So once we figure that out, we can say, what is the cosine of theta? Well, we're using our reference angle and reference triangle to figure that out. So when we look at this, the cosine of this angle is going to be adjacent over hypotenuse. So the cosine is going to be negative 1/2. Okay, that was a really long lecture. I apologize, lots of information there, but hopefully it was useful for you. All right, good luck. Get those things memorized.